Advanced Math, Lesson 24, Sums of Trigonometric Functions and Combining Functions. So we'll go straight into our examples. By sums of trigonometric functions, what they mean is problems like this. We have two different trig functions, and we have to find the sum of them. Let's see the plus sign. Okay, so before we start doing this, we're going to have to draw our reference triangles. So the first one, the 45, 45, 90. 45, 45. Draw our 90 box, and then we have 1, 1, root 2. Then our 30, 60, 90. That's not good. Let's try this one. And you guys should be practicing these triangles more and more, and eventually you'll be able to draw them from memory. So we know the 60-degree side makes the bigger leg, the 30-degree side makes the shorter leg, and then the shorter leg is going to be 1, the bigger leg is going to be root 3, and the hypotenuse is 2. So once we've got that written up, we can go ahead and start solving. So the tangent of 45 is going to be the opposite over the adjacent. So tangent of 45 is just going to be 1 over 1. And then we have 2 times the tangent of 30. So we're going to have plus 2 times the tangent of 30. So we go to 30, opposite over the adjacent is 1 over root 3. But we have to rationalize that. So that's going to turn into, once we multiply by root 3 over root 3, that'll rationalize to become root 3 over 3 for the tangent of 30. From there, all we have to do is multiply this over. So now what we have is 2 root 3 over 3 plus 1. We'll go ahead and turn 1 into 3 over 3 as a fraction. And then when we add those, our final answer is going to be 3 plus 2 times the square root of 3 over 3. And that's it. Pretty simple. We'll do one more example. So our next example, they want us to evaluate, that's a little sloppy, we'll rewrite this. Square root of 6, they want us to evaluate square root of 6 times the sine of 30 degrees plus 1 over square root 2 times the tangent of 60 degrees. So again, we'll use our reference triangles. To find the sine of 30, we're going to take the opposite side, which is 1, put it over the hypotenuse of 2. So sine of 30 can be rewritten as 1/2 times the square root of 6. And then we're going to add that to 1 over root 2 times the tangent of 60, which for 60 we take the opposite over the adjacent. So that's going to be root 3 over 1. Okay, so this first one's pretty easy to simplify. That'll just become root 6 over 2. This one, we have to first rationalize this 1 over root 2, which will become square root 2 over 2. When we multiply that, what we end up getting is square root 6 over 2. So what we actually have is square root 6 over 2 plus square root 6 over 2. And what that simplifies to when we add it is just 2 times the square root of 6 over 2, which those can cancel. And then we just get the square root of 6 as our answer. So this can be pretty simple as long as we know our reference triangles, which we've got to memorize these. Absolutely need to memorize them. And you got to be able to construct them from memory so that way you can use them as a note or a tool on your test. Next, we'll go to combining functions. I'll go ahead and turn this over. We'll go over here. So we learned a little bit about functional notation. We see here different ways to combine functions. So what we see here is that if we're adding two functions like f plus g, we can rewrite that as f plus g of x. Same thing with subtraction. So it's just different ways of writing this function plus that function, this function minus that function. Here we have multiplication, and they just write them together. And then division, they write them with a slash. So we'll go ahead and go into our first example. So when we're given these two functions, f of x being x plus 2 and g of x being x squared plus 3, we have to find f plus g of 6, f minus g of 6, f times g of 6, and f divided by g of 6. Now there's two ways to do this, and I'll go ahead and demonstrate both of them in the addition and the subtraction. So the first way is to simply plug 6. We'll start with A for the addition f plus g, is to plug 6 into f. All right, so what we do is we'd say f of 6 equals 6 plus 2, and then plug 6 into g. Say g of 6 equals 6 squared plus 3. All right, and then we would find both of these answers, which one is 8, and g is, let's see here, 36 plus 3 is 39. And then we can add those two answers. All right, 8 plus 39 gives us 47. So that's the first way. Now the second way is to actually combine the two functions. So instead of plugging them in, we would do x plus 2 minus x squared plus 3. The way that works is we just have to follow all of our rules of algebra. So we would take this negative or the positive, whatever it is, and we would apply it to that second function of g. So in this case, what we end up getting is x plus 2 minus x squared plus 3. And then this negative distributes, so what we actually have is x plus 2 minus x squared minus 3. Go ahead and combine like terms here, and then we get negative x squared plus x minus 1. From there we just plug in 6, so we have negative 6 squared plus 6 minus 1. 6 and 1 combined become positive 5, and 6 squared gives us 36. Negative 36 plus 5 gives us negative 31. So those are the two methods to solve them, and I'll go ahead and finish the rest of these examples, and I'll probably use this secondary method for this. So we'll go ahead and go with C, so f times g. So what we actually have there is x plus 2 times x squared plus 3. From here we'll FOIL, so we get x cubed plus 3x plus 2x squared plus 5. From here we'll go ahead and plug in the 6's. So then we have 6 cubed plus 3 times 6, which is 18, plus 2 times 6 squared plus 5. So we'll simplify the 6 cubed. I'm going to go ahead and use my calculator for this one. So 6 third power gives me 216 plus 18 plus 6 squared, which is 36. 2 times 36 gives me 72 plus 5. From here I just need to add. Now let's see here. I'll go and combine these. 18 and 72 combined to give me 90. 90 plus 5. 95 plus 216 gets me 311. So this one equals 311. Wait, no it's not. Hold on. I messed up way back up here. 2 times 3 is 6. So that should be plus 6 all the way down. And then that makes it 312, not 311. Okay. Did everything right except 2 times 3. Okay. Last one, f divided by g. All right. If I want to do this one using the algebraic notation, I'm just going to take the function of x, which is x plus 2, put it over the function of g, which is x squared plus 3. To divide them, and then from here, since I can't simplify anything else, I'll just go ahead and plug in the 6. So then what I get is 6 plus 2 over 36 plus 3, which equals 8 over 39, which cannot be reduced. So that's our final answer there. 8 over 39. Okay, now the very last thing we learn how to do with our functions is how to plug one function into another. So, I'm going to go and pause real quick for the sake of time. Wait, never mind. I don't have to. Okay. The last notation we'll have is f of g. Right? It looks a lot like fog. That little circle is just saying that we're taking the function of g and we're plugging it into the function of f. So if you remember, the function of g is x squared plus 3, which means we're going to take this entire value and we're going to substitute it for this. So another way of this essentially means f of function g. Right? And it's written like that, f of g. And it looks a lot like fog. So we'll take the function of f, which is x plus 2, and we'll plug in g for x. So instead of writing x, I'm going to write the entire function of g, which is x squared plus 3. And then I need to solve that. Now if I solve this for